Hello again. Nice to be with you here on this particular channel. Today we're going to be looking at something very exciting, and it's actually a topic or a subject, and that is basic science. And this topic actually is going to be for those that are actually coming into the high school. We can call them the freshmen, okay? The fresh students coming into high school, and that should be the JSS 1 classes, or you can say the year 7 classes. And this is the first topic you are going to learn, or you're supposed to learn in basic science. I call that an introduction to basic science. But the topic we're going to be looking at today is learning about science. Learning about science. And there are several things we're also going to be picturing or looking at under this topic, learning about science. We can call them subtopics. One of them, we're going to be looking at the meaning of science, what exactly science is all about. You know, most of you, if you were asked to define science, some persons will come up with definitions of technology. They will tell you about the gadgets all around their houses. These are simply applications of science. But we're going to be looking at the meaning of science. We're also going to be talking about the major branches of science. Science has so many major branches, and we're going to just look at just 2 or probably 3 major branches of science. And also we're going to be talking about scientific methods. These are actually approaches or methods which scientists use in solving problems or handling issues or responding to phenomenal events they observe. And we're going to be looking at all of these step after step and see how we can understand it better, knowing the scientific methods. And we're also going to be looking at science-related occupations. So in case you are actually interested in science after this particular class, you can have a focus of the particular occupation you want to actually practice. And then finally, we're also going to be looking at the benefits of science and also the adverse effect of science. Science also has its own adverse effect, but it also has the benefits. So these are the areas we're going to be talking about in this particular topic, learning about science. Now, if you're actually ready for this, will I call it an adventure? Let's start. Today, we're going to be looking at the meaning of science. What exactly is science? Now, science can be seen as a system of acquiring knowledge. It is a system of acquiring knowledge using observation, using experimentations to actually describe and explain natural phenomenon or events of happening. In other words, what we're trying to say here, that science is all about the acquisition of knowledge. It is about the acquisition of knowledge. And this knowledge can be acquired using several approaches. One of them is using observation. You observe. Through observation, using our sense organs, we can also obtain or acquire knowledge. And also by experimentation. We don't just observe, we subject those observations to several tests. And what we observe, most of them are natural phenomena, natural experiences. For instance, everything you throw up must always come down. That is a natural phenomenon. So trying to understand, trying to observe, trying to carry out tests or experiments to show these natural phenomena is what we refer to as science. The knowledge that is acquired from this is what we refer to as science. Now, science also, like I said before, has so many branches. It has so many branches. And we're going to be looking at some of the branches of science. Now, we are going to be looking at 2 branches of science. The first one is called natural science. We have the natural science, and number 2, we have the social science. Now, what is actually natural science? Now, natural science is a systematic study of natural things that is around us. Now, when we're talking about natural things, we're actually looking at both living and non-living things. There are several things that are living that occur naturally, and there are also several things that are non-living that also occur naturally. For instance, the non-living things that occur naturally, we have the water. Water is non-living, but is a natural thing or a natural resource. We also have air. Air is a non-living thing. It is also natural. We have the stones, the rocks. We have the sand. These are all natural things, but they are non-living. We also have living things that occur naturally. These are plants and animals. They can be grouped into plants as well as animals. So, but let's look at other divisions of natural science. Natural science can also be subdivided into two basic types or two basic branches also. Remember, we said that we're looking at natural science. We're looking at natural science, and I said that natural science can be broken down into two main groups. And these two main groups are biological science and physical science. Biological science, physical science. Now let's take a look at what biological science is all about. Now remember, we initially said that natural science has to do with the systematic study of natural things around us. And we also mentioned that they can be grouped into living, or the natural things can be grouped into living and non-living things. Now, based on that particular definition and explanation, that is where we have the two main types of natural science, or two major groups of natural science. Now, the biological science, as the name implies, biology, okay? It talks about the study of living things. So biological science has to deal or deals with or involves the study of living things. Remember, we said natural science, natural things are both living and non-living things. So the aspect that deals with the study of living things is what we refer to as biological science. And in secondary school or in high school, the subject that is actually studied relating to biological science is actually biology. Now, biology is actually is gotten from two Greek words, which is bio and logos. Bio meaning life and logos meaning study. Hence, the meaning of biology is the study of life, the study of life. The next major group of natural science is the physical science. Now, your guess is as good as mine. The biological science, we said it is a study, it deals with the study of living things. It simply means the physical science deals with the study of non-living things. Now, the subject studied in high school or in secondary school based on physical science includes physics and chemistry. Now, there are other subjects that are studied based on physical science, but the one that is paramount, mostly in secondary schools or high school, is actually physics and chemistry. Now, what exactly is physics? All right. Now, physics is actually a study of matter in relation to energy, while chemistry is actually the study of the composition, the study of the properties and reactions of matter. In our subsequent videos, we were going to be looking at what matter is all about. But for more clarity, matter is simply anything that has weight and can occupy space. They actually exist in three forms or in three states. We have the solid, we have the liquid, and we have the gas. So anything that occupies space that is a solid, anything that occupies space and has weight that is a solid, a liquid, and a gas is referred to as matter. So it means that oxygen is also a matter. So we're going to be talking about more of that in subsequent times. Now, if you look at what we have actually spoken about science, you will discover that science is actually a vast subject of study. It's something so huge that carries a whole lot. All right. But before we go ahead to look at some of the occupations that are actually studied in science, I will want us to look at the next branch of science. Remember, we said we're looking at two branches of science. The first one we have mentioned is natural science. The second is what we call the social science. Now, the social science actually deals with the study of human behavior. It deals with the study of human behavior. Now, subjects that are studied in social science, mostly in other fields of study, probably in other institutions of learning, is anthropology. We also have economics. We have political science. We have sociology. We have social psychology. These are subjects that are studied under social science, Now, most times, people that actually make use of scientific approaches to solve problems are referred to as scientists. Now, let's quickly move into what we call scientific method. Most times I call it scientific approach, not really a method. It is actually an approach a science student will actually apply or adopt in order to solve problems, like we said before, identify natural phenomenon or events or happenings. And these are the things we're going to be looking at. The first one we're going to be looking at is scientific methods. Now, there are steps taken to ensure that universal results are obtained by a scientist. Now, a universal result is a result that is the same all over the world. Now, for us to ensure that our results as scientists is the same all over the world, there is need for scientific approach, scientific methods to be applied in whatever research we are carrying out. So let's take a look at some of the scientific approaches or scientific methods. As you can see on the screen there, we have it just broken down into a chart. Well, I call it a flow chart. We have observation. The second stage is questions. The third stage is hypothesis. We also have experiment, analysis, conclusion, and then it comes to become a theory and then a law. Now, I'm going to be explaining each of these stages as it is should or as it should be. All right. Now, let's start with the first one, which is called observation. Now, if you remember the definition we gave for science, we said that it is actually a system of obtaining or acquiring knowledge using observation and experimentation. So it means that knowledge can be acquired when one becomes so observant. And that will bring us to some important qualities of a scientist. One of the important qualities of a scientist is that a scientist must be observant. He must be observant. Now, what do we use to observe? We use our sense organs. Now, the sense organs are used to identify our environment. It is also used to identify natural phenomena, natural events or happenings. All right. Now, these sense organs include your eyes, it includes your ears, it includes your tongue, it includes your nose, it includes your skin. So they can be used actually to observe. They can be used to identify a particular phenomenon. I gave an example initially. If I should throw something up, it always comes down. That is an observation. We use our eyes to observe that whatever goes up will come down as far as it is in this earth. As far as it's in the earth, it goes up. Anything you throw up must come down. Now, the next phase or the next step or method in the scientific approach or method is asking questions. Now, after observing the natural phenomenon, the scientist goes ahead to ask question. He goes ahead to ask question. And that brings me to one other important quality of a scientist is that a scientist is always curious. He is always curious. He wants to ask questions. He wants to know what why this is happening, why this is not happening. Remember, we just made a reference, or we are using an illustration. Anything that goes up will always come down. Now, as a scientist, he will keep asking, what actually pushes anything that goes up to come down? What exactly? Why is it happening that way? Why not when I throw something up, it keeps going up? Why is it always coming down? Why is this thing always happening? Now, that is the system of asking questions. So in the process of observing things, the scientist may notice a pattern or a problem. They then ask questions about the things they have actually noticed or observed. Now, the question might not be thrown to everybody. The scientist might be asking that question to himself or herself, okay? Asking those questions repeatedly asking those questions. Now, that will create that desire to actually find a solution to that particular question. And that brings us to the next stage, which is called hypothesis. Now, hypothesis is actually giving a reasonable explanation to the questions that are being asked, or to whatever the scientist has observed, giving reasonable answers, reasonable suggestions, okay, reasonable guesses, all right, or answers to those questions that are being asked. I'll give you an instance. Probably let's still use the same illustration, and that whatever we throw up, if we throw up a stone, it must come down. And the scientist is asking the question, why is it happening this way? And then he can come up with several hypotheses, several guesses he can put on the table. He can say probably there is an invisible hand stopping the stone from going up, or there is a force actually pulling the stone down, or something else. So from what I have just said, I have two hypotheses. I have given a reasonable explanation to what has been said, or to that illustration, giving two reasonable hypotheses. Now, after that stage, the next thing the scientist does is to carry out a test, which is experimentation. He carries out the test in order to prove the hypothesis correct. Now, most of these tests are being carried out in the laboratories. All right, so he carries out these tests in the laboratory to prove that the hypothesis he has kept in place, or he has put on the table, are correct. So, now, when carrying out experiments, it is very, very important that records be kept. So, recording of results, recording of the step-by-step approaches that are being taken is very key. And there is a way records should be kept in terms of biology. Let me use biology as a case study. For biology, there is a way you keep your records when carrying out an experiment. You start with the aim, and the aim is the reason why you're carrying that experiment, or why you're carrying out that test. I can say to determine why stones that are thrown up always comes down. That is the aim. Now, after the aim, your next thing you put down or you record is the apparatus or the materials you made use of, the materials you used while carrying out the experiment. And then number 3 is actually the method, the step-by-step approaches that were taken in order to arrive at a particular answer or conclusion. Now, after that, after writing out the step-by-step approaches, there is also observation. The observation is what you saw, what was the result from those experiments that you have carried out. Now, those experiments you have carried out, the observation that has been gotten, please, the next step is for you to analyze it. You analyze it. You check through. You go through it. You analyze it. Now, after analyzing it, you draw a conclusion. A conclusion must be drawn after analysis of the result has been made. Now, if you draw the conclusion and that conclusion proves your hypothesis correct, it now becomes a theory. It now becomes a theory. After if the hypothesis is correct, proven by the experiment you have carried out, it now becomes a theory. Now, if it is not, that theory is not generally accepted, if it is not proven over and over again or not generally accepted by other scientists, then it will not improve or migrate to become a law. But if it is generally accepted, it is now a law. It now becomes a law. But if it is not generally accepted, the scientist will go back and carry out the experiment again until he gets the thing right. He goes back to carry out the experiment again. So these are the step-by-step approaches that are actually taken by a scientist in order to acquire knowledge, all right? The first step, like I said before, is observation. The second step, asking questions. The third step, hypothesis. The fourth step, experimentation. The fifth step is recording those results while carrying out the experiment. The sixth step is analyzing those results. The seventh step is drawing conclusions based on those results. Now, if the conclusion that is being drawn from those results proves that the hypothesis is actually correct, it now becomes a theory. Now, if the theory is generally accepted by others and it stands the test of time, over time, it becomes a law. But if it is not generally accepted, the scientists will go back and carry out another experiment. So this is what we call the scientific methods, right? The next thing is science-related occupations. There are several occupations that can be studied under sciences. There are so many of them. I just picked these few of them. Number one, we have agriculture. So if you want to go into science, you can also go into agriculture. Number two is botany. Now, botany actually is the study of plants. Number three is zoology, which is the study of animals. We also have biochemistry. We have dentistry. Okay, we have medicine. Now, dentistry is also a form or a part of medicine. So medicine, we also have dentistry. We also have nursing. So science-related subjects, science-related occupations, we have nursing, we have pharmacy, we have radiology, we have engineering, we have geology, we also have oceanography, we also have geophysics, we also have astronomy, and finally we also have a teacher. So look at the options you have there, the list you have there, and I don't know what you actually want to be, but I pray you become a scientist, okay, like myself. All right, now the next thing is benefits of science. Like I said before, science has benefited mankind in so many ways. In fact, the impact of science cannot be overemphasized. The impact of science cannot be overemphasized. Let's look at just very few benefits of science. Number one, science has helped to make work easier and faster. That's helped to make work easier and faster. I can remember when growing up, when you want to blend your melon, okay, my mom will always ask us to pound it. And of course, it would take time for it to be well pounded, and also it will take a lot of energy to do that. But this time around, we have several machines that can do that with ease and within a short period of time. So, and these machines are simply applications of science. So science has helped so much to make work easier and also to make work faster. All right. Number two, science has also helped to provide better health care services. Better healthcare services. Now, there are several illnesses, diseases that had no cure in time past, but based on the advancement and the development of science, we have the cure for several diseases. We have a better way to take care of ourselves. We have understood, acquired so much knowledge through science in order to provide a better health care for us all, both man and animals. I mean, both man and animals. Better health care. Science has also helped to provide that. Number 3 or number 4 on the list, number 3 or number 4 on the list is that science has helped to make communication easier. It has helped to make communication easier. Now, I am talking to you. I can pick up a phone and speak with someone in Japan. I can pick the phone and speak to someone here in Nigeria, in Lagos, Nigeria. I can pick the phone and speak to someone that is so distant within minutes. And this is as a result of the contributions of science to mankind. Communication has been so easy. Initially, we were writing letters. Can you remember? We write letters, and then when you post it, before it gets to the person you are actually posting it to, it would have taken 2 or 3 weeks. But this time around, you can communicate to someone that you would have spoken to in 3 weeks. You would have spoken to the person within seconds, within minutes. You have reached to, you've had a reach to that particular person, and communication is already taking place. And then also we have another effect. Science has also helped in crime detection. Now, crime has, will I say, to an extent, greatly reduced somehow based on science. We can use fingerprints to identify people or someone that has actually committed a crime. Okay, and so many other things. DNA testing has also helped in detecting crime, and all these are all applications of science. And also, science has also helped the production of more efficient means of transportation. In the old times, in ancient times, most persons use animals like the camels, use horses in transporting themselves, goods and services from one place to another. But this time around, we have faster means, more efficient, more relaxed, more easier means of transportation. We have the aeroplanes, we have the jets, we have the cars, we have the lorries, we have the ship, the yacht, and so on. These are more efficient ways of transporting goods, services, and even humans from one place to another. And all thanks to science for that great experience. And number 6, it has also helped, science has also helped or has led to the production of better equipments for agriculture. Better equipment for agriculture. You could remember back then we used the simple tools like the hoe, we used the rake, and so on. But this time around, based on technological advancement, which is also an application of science, we have tractors, we have mowers, we have plows, we have bulldozers that can help clear a large piece of land and also help make farming and agriculture so easy, so easy, and all thanks to science. Science has also improved plant and animal varieties. We have different varieties of plants and animals. Plants that can resist several environmental conditions, plants that can resist pests, and so on. All these are simply applications of science. Science has also helped in the production of fertilizers, as in terms of agriculture, which has led to increased food production. Science has really helped, and all thanks to science. What are the adverse effects of science? I'm just going to point out 2 adverse effects of science. Number 1, the activities of science. Science, yes, has impacted in man's life positively. However, the activities of science has increased environmental pollution. Now, environmental pollution is actually the release of harmful substances into the environment to the extent that it causes biological damage. Science has increased the release, the scientific activities, researches, and so on, has increased the release of harmful substances into the environment to the extent that it has caused significant biological damage. I'll give you an example. An example is noticed in transportation, okay? Vehicles that moves on the road, all right? Now, this is also an application of science. It's an application of science, the cars. Now, these cars, these automobiles are actually driven by products of crude oil. Now, those products of crude oil, when they are heated, they emit so much gas. They emit gases, and these gases also pollutes the environment. Now, we also have gases that are found in aerosols, which is the CFC. When released into the environment, they bring about the ozone layer depletion. When gases like sulfur dioxide and nitrogen dioxide are also released into the environment, they cause a huge environmental pollution. So one of the major adverse effects of science is the bringing about, or is the increase in environmental pollution. The next one is it has brought about the invention of nuclear weapons. Now, nuclear weapons of mass destruction. Now, these nuclear weapons, such as the atomic bomb, has posed a very big threat to so many nations. It has been a threat to so many nations. Now, nations that don't actually have nuclear weapons tend to be actually weak. And then nations that have nuclear weapons, the atomic bombs, and all the others are seen to be, in quote, the superpowers, or you can call them the power nations, okay? It's because of this. And of course, you know the kind of damage that will be caused if an atomic bomb is actually released in a particular country. There will be so much destructions of lives and properties. So these are also, or these two are major effects of, or major adverse effects of science. All right. I hope you enjoyed this particular class. This is where we're going to call it a wrap up on this particular topic on learning about science. I encourage you to make use of the Examguide app. You're going to see questions on this particular topic that will help you understand it far better and more. I'll see you in our next videos. Bye for now.